Alright, we got them done? Come on, this is just like yesterday. Bye. Bye. When we do the opens, you can actually paper. You can start today. You only get one, but you can do one. Alright, so this is review for you since you did this in Essential, right? So this looks familiar to what you did out of Protons, Neutrons, and Electrons. Okay, so just practice what you've already done. Since you've already done the chemistry section, you should do really well from now till the end of the semester. Alright, and there will be some stuff on the exam, unfortunately, you've just never seen before. What parts of physics had you done?
We had just started, so I haven't really been in school since we got off the tech here.
Really? So you had, okay.
Yeah, good bit away from school.
Because I spent roughly 11 weeks in physics, and then we spent roughly 4 weeks in chemistry, 5 weeks, something like that. So,
Tap.
everything does support the thing.
Come on. Just give it an hour or 2 days.
You're gonna work on it again today.
I could go
Alexis, your phone.
Daniel.
Yeah. Yeah, it just looks ridiculous.
Man, who is he? Are we having another test? Are we having another test? Well, quiz.
We will take another, we have a quiz tomorrow. We'll take another test. Probably right around the benchmark. It might be sometime late next week. The benchmark is right at the beginning of Christmas break. It's not early part of the week. Like ours is third period, so it's supposed to be Monday. I eat here, so don't be funny.
This ain't the whole thing. That's what I meant.
This is good.
That's right.
Done. So what next? So try to make more
I got a whole box at home.
I gotta find this one. I'm gonna have to organize this one.
All right, we have a chance to try them all.
Can you have it? I have more for me.
Well, 32.
All right, so believe number one. What do we have to do to find the protons?
No, it's 17.
Yeah, it's 17. It's subtracting.
17.
It's subtracting to get the neutron.
All right, we subtract to get the neutrons.
Right.
All right, so if I want to find the protons, how do I find the protons? It's the smallest number. So the protons are the atomic number, so it's 17. All right, how do I find the electrons? It's the same as the protons. All right, so I subtract to find the who? The neutrons. So 37 minus 17 is 20. So that's my neutrons. All right. I'll say y'all are going to put me over the edge one of these days. All right, so the protons. How many protons are there in tungsten?
74.
All right, how many electrons are there?
74.
And to find the neutrons, I have
180 to
185 minus 74 is. All right, so for cobalt dash 60, here I only have one number. So if I only have one number, what am I going to do? Look on the periodic table. Zai, do you still have one or you need one? Okay, here we go. Are you going to leave it under the desk like that other one? Then I'm not giving you one. You need to be responsible and you're not getting one. Oh, yeah. All right, so cobalt has what atomic number?
27.
27. All right, so if it has an atomic number of 27, that means its number of protons are what? 27. All right, its electrons are, and to find its neutrons, we have what? 60 minus 27 is what? You said what? Okay. All right, so for arsenic, what do we do here? All right, what's its atomic number? Okay, so how many protons? How many electrons? And to find the neutrons, we do what? 78 minus 33 is questions. All right, so if you have openings for me, and Zai, you can turn in today's for some credits. We have a grade. Typically, we collect these in batches of 10, so we just do 10 in the night collection. All right, so those of you who've been here with us, if you have whatever portion of 10 you wish to turn in, all right? Like I told William, if you have 7, 7 is better than turning in nothing. All right, lots of you opt to turn in nothing, and you just rack up zeros. It's killing you. So, staple, put it on the stool. Okay? Make sure you put your name on it. I do not know where the book went. And if you're ever absent, I print the openings every day, and they're in a book. Raoul has the book. All right, so y'all can put the stapler over there. Put them on the stool, Emily, see it. Stapler over there. That way you're not all around me in case any of y'all are sick and you're breathing on me. I don't want to be sick during the snowstorm. You'll do it. Yeah. Maybe. There's a chance we can.
Sunday.
Depends on whether the low stays to the south or to the north. If the low stays to the south, we have a really good chance. If the low stays to the north, we're going to get more rain.
It better snow. I want it to snow. I don't want it to snow. I don't know yet. It depends on if my mom will.
You see that?
funny question.
All right, if you will, find your homework after you turn in your openings. We're talking about how you did on that. The chart you just showed me. A wise one. All right. Any other openings, or do I have all I'm getting here? All right. Have any grades I need to hand back? You know you had help on this quiz that you made up when you know the answers to the questions that I have missing the information to that I was supposed to tell you to write down the quiz. Just a side note. Because it wasn't even on the paper. All right, let's talk homework. Those people who did it. All right, turn this on. So what brought you back here from Central? Did you move back to the city? Yeah. All right, who was absent yesterday and needs one?
Me. Yeah, we have to show our work. Yeah, we have to show our work. Murder. Appreciate it.
All right, so we look at the first row. Right? We look at the first row. This one, I told you, should be an easy row for us to do because I gave you the mass and the number. So, what element do we have? If I told you the symbol's He, the substance ought to be really easy to fill in. Helium. All right. What's my number of protons? My electrons. And to find the neutrons, we do what? So 4 minus 2 is 2. All right. For the third row, my element is Zn, so I know it is zinc. So I know my protons are.
Protons are 30.
So my electrons are.
30.
And I say what to get my neutrons?
65 to minus 30.
65 minus 30 is
35.
35. All right. On this row, I gave you the element name, so the symbol is Br. My atomic number will be what based on what I know here?
80.
I know I have 35 electrons, so my protons have to be what?
35.
35. And my atomic number has to be. So to find my neutrons, I'm going to do what to find neutrons? 80 minus 35 is 45. All right, next row. I've got 13 and 14. Well, we all did this yesterday.
Okay, it will be.
I believe you had a note. That doesn't mean I'm going to go back and reteach it at this moment in time, though.
Electrons will be 13.
All right, protons are 13, so that means electrons are what? 13. Atomic number is 13.
The atomic mass is 27.
13 plus 14 is 27. So what number tells me the element, the atomic number or the atomic mass?
Atomic number.
The atomic number. So that tells me I am aluminum and I am aluminum. All right, if we were in England, we'd call that aluminium. They have a few more syllables.
The protons are 92.
All right, the protons are 92.
The atomic number is 92.
The atomic number is 92.
And the atomic mass is 238.
You got to say 146 plus 92, and you get what? 238. All right, and the symbol for uranium is just U, no R. Capital U. Some of the symbols are one letter and some of the symbols are two. If it's one letter, you use one capital. If it's two, the first letter is capital, the second letter is lowercase. Questions about any of the ones that you had for homework last night? No? All right. Feel okay with what we were doing? Yes? No?
We have to do it.
No, you see that line right there?
I did all right.
Yeah, that's why I drew that line and told you to stop.
I didn't
Stopped at Krypton.
Okay.
All right, geniuses.
11.
That would have been 11, 11, 23, Na, sodium. That would have been 36, 36, Kr. What's 36 plus 48?
84.
84. This would have been 20. That would have been 20. That would have been 20. Ca, calcium. That would have been 47, 47, 108, Ag, silver. All right, for my overachievers who did the whole paper.
Can you tell us?
No, you see this pink line that's right here? I told y'all to only do those rows that had the pink line. We did one of the lines, so you only had to do 5 lines.
You didn't tell me yesterday, so I did all.
I'm aware of that, but everybody else was here. Okay, you did what, John? You stopped. John listened to me. He stopped where I told him to.
Well, guess what? Think of it. Just think of it. You just got a little more extra practice.
Okay. I'll say John wasn't going to exceed what I asked you to do. He had enough sense to stop. All right. Now.
We do this all the time. I like this.
Yes.
I have a cell phone. This.
All right. Same thing, except it's not a chart. All right. This is just a single question about something about a chart. Same concept. It should be just as easy if you understand what we did.
Oh my gosh.
It's just not in a chart. Asking the same thing. All right, I want you to do the exact same thing. Find some answers, just not in a chart. And I have another one that's in a chart. I just don't want to give it to you in chart form yet. I want to see if you can think.
Are these negative?
Say what?
Are these negative?
No, those are dashes. That's hyphen notation. They're not negative.
Yeah, I hope I did this right. Put it right there.
Where's it going?
Yes, you said so. It's my home, right?
Okay. There it is.
Oh, I did it right. Then it was 14. I didn't know it was 14. I used my brain because I was like 14, 14, that's 28.
Alright, Jesus, all the elements are on the periodic table. Why did they go do the tables?
Hey,
They're all on the table. Who else has a question? Question? Alright, so you need electrons. What number tells electrons we learned yesterday? Gotta find the what number is. Okay, yeah, the protons tell the electrons. So what are the protons? Silicon. On this side. On the area surface. Okay, how many protons is that? 14. Little number protons. So that's 14 protons. How many electrons is that? Yes. Protons do it in each side. Okay. And then go to the next one. I didn't ask you to find all three of them. I only asked for electrons. What's wrong? Silicon. Here on this side. Okay? Nope. Will be what? Two electrons equal. They're the same as the what? Protons. How many protons does silicon have?
You subtract these numbers.
Yeah, so that's 14 protons. So how many electrons will have? That's right. So how many will have?
I gotta add them up.
No.
There's an electron.
If it has 14 protons, it has 14 electrons. I only asked you the electrons.
The atomic number.
The protons and the electrons are the same. Protons and electrons are always the little number on the periodic table, the atomic number. Right?
Equal 14. And the atomic number.
I will not disagree with you on that.
Yes. Sir.
So what? I
I
said that's the same atomic number different atomic mass. Same number of protons.
So it actually, proton, electron, just put the same thing with.
It was actually carbon 12 carbon.
So this will be the number.
Yes.
Yeah, I get it.
Remember,
I'm not making sure, like, it's just.
Oh.
No, this is all in our second day. We've literally started chemistry by one day. This is day two. Yeah. Okay? See how you did this right here? I asked you the number of protons. Once you wrote that answer, you were done. Okay. Okay, you were done. But yes, you did all the rest of it right. But I really wanted protons to make question. That's fine. Yeah, you're making a mess already. That's yes.
The fact that I didn't find it, the proton.
And what? Yeah.
And we only need to find one.
Protons and all of them, or just which two? Yes. Oh, so it's neutrons.
Oh, you had.
Oh, I ain't answering.
I was like all over. I know. That's why I pointed
I
out.
just.
Would be 30.
Because you had what, 2 nights?
Don't listen. Period. Don't listen to them.
Yeah.
Just tomorrow, I'm done. We don't. And.
All right, who else has a question?
What's that from the Cheetah Girls song? What's the match?
If you can't find something, I'll be glad to point it out to you rather than you hunt for it.
Yeah.
Yeah.
Will, do you have?
Do something about
But you said, subtract what?
190.
You can find a neutron.
Do you have?
Which one are you doing?
Your orange
Am I
color.
close to me today? I got the truth. I think.
Oh, yeah. We get tests like this.
You feel me? Let's ask for 50% of your rate on this, just this, nothing else, just this. Boom.
What?
You never put it on.
It's neutrons.
Yeah, you're gonna subtract
But
what?
why is the
Oh, I'm rich, I can paint.
Yep.
No, you have to add that in.
big or you see what it is?
Sir. I like to keep going.
All right, now you ask me.
Is this right?
Yes, so that's the protons. That's protons.
When did they get you? But the contract.
Huh?
I don't know.
I got, oh,
I know,
You
but
didn't figure out
talking
that.
to YouTube, Ken and, Colonel, he like gave like a somewhere else.
you got your own orange card.
Just hope he-
Okay,
just give it right.
don't lose it.
That's fine, sir.
Wait, hold.
She pointed out like that.
I got them.
You gotta find all three of them.
Oh, this?
Oh, okay.
Yeah.
Okay. So that's.
What?
Yeah.
I'm ready that third. Yep. You gotta do what about neutrons?
Yes.
Yep. Who's gonna ask? What are you gonna ask? Then you don't got it right. All right, let's talk about 4, because it ain't right. All right, so what's the 35 supposed to be? Nope. Where's that? How do you call it? Not a big problem.
What number is 12 and 12?
You subtract this mass from the top number, say 66 minus the top number, we figure out that. Why don't you have one? I had the grant yesterday. What do you mean you didn't get one? I handed them out personally. You were sitting in a chair.
Right where?
Good dude. This is the last time I've handed you one, because I buy card stock, not the school.
This part.
I think that I was.
I'm like, hold on, let me do it. Six minus 30, so it's only five.
Next one.
Three.
Plus 16 or 14 plus 16.
Nine of the words, so nine. By your unlimited, same little.
Alright.
So they're just one, you're 100. I like this
Alright, what's your question?
Okay, so this one.
Oh. Oh, 2 things make up mass. Oh. 2 things. Yep, you gotta add. Protons. Nope.
No neutrons.
Protons, neutrons.
Okay.
Alright, who else has a question? Okay. Okay, what's up electrons?
Number 7.
Yep.
It's on the number. It's on
Oh, so you don't have the 12, there's 12 electrons. Alright, anything. Atomic number, protons, electrons, we're all the same thing.
So electrons equal.
This is
Equivalent. So easy electron.
yeah. I gotta write that down. Sorry.
Pro, question. I'm done? To me, you're done. You've done exactly one, and you have no questions.
Oh, no, I'm good. I think I got it. I mean, I know that I know
Yeah. You're trying to figure out if it is an isotope or it's not an isotope. If they have the same protons or the same atomic number, the answer is yes.
You just wanna be like.
Protons or the atomic number is different, it's not an isotope.
Still together.
What is the atomic mass? What do you think will you add together to get atomic mass? Protons and neutrons.
That would be.
So you have protons are 16, electrons are 16, neutrons are 18. So over here, on this one, protons would still be 16, electrons would still be 16, but your neutrons would be different.
Okay.
Yeah.
Oh.
Yeah.
Pardon the interruption, just an announcement. Work keys testing for today is now complete. Students should be back in their third period class, and we will resume ringing the bells as normal. Thanks to everyone who came and helped today.
Yep.
What a different number.
14 plus 16. Huh? Which one?
What a different number.
Yeah. I just didn't give it to you in table format this time. So you just give me this paper and the last paper.
I do it like that, right? I would add the 13 to 15 on atomic mass.
Yes.
Yeah.
Yes. Now, the only thing that's different is that's the math. It's not nickel. It's going to 28. Which one of these numbers do you use to figure out the density?
Oh,
I'm using the 13. So it's just whatever the element is. All right, about another 2 minutes and we're going to go over what you've got. Mm-hmm. What do you mean? Yep. Yes, yes, you can. That's what you're saying now. Yes, you can. Mm-hmm. What are you pointing at? Yes.
And see, when y'all look like the element, and see the mass.
Because you have 25 electrons.
It can't
What's
be
the
more
proton?
than it, but it's like 14, but mass is like 6. I mean,
So what's the atomic
it's
number?
like close. It's 9.
So that's what you use to find the elements. You look at 29. You're trying to do some math.
Oh, okay, so you use what we did.
Yes. We're gonna. Hmm. Now, can we talk about what you come up with, even if you didn't finish them all?
Yes.
Okay, let's see what you did. All right, now, I wanted to give it to you in a different format, because are you going to see this as a chart on the exam? Probably not, okay? Now, I've already told you your quiz tomorrow will be in chart format. However, you need to get used to seeing the questions in a different format. And on the test, or the state test, you may not even get one that says, tell me protons, neutrons, and electrons, okay? It may ask you to analyze something. So you've got to get used to seeing the questions in a different format. You're going to build models for me, possibly late today. I hope not, because I didn't even get the stuff out. I was too busy watching the film on second period. So, George Bush's former president's funeral. So I didn't get the stuff out, but I'll have it out tomorrow. So when you look at number 2, or number 1, sorry, I skipped one. Determine the number of electrons in silicon. How do you find electrons? You can go through the process. Sarah was just practicing. She's doing all of it. That's fine. Okay? You can do that every time if you want to. But do you have to?
No.
No. So you know it's what?
The atomic.
Your atomic number. Protons and electrons are the atomic number. So you just look up silicon and you go, silicon's atomic number is what? And you're done. The answer is 14. Okay? Number 2. How many protons does strontium have? What did you just say the protons were? The atomic number. Now, if you have trouble finding stuff, I'll be glad to point it out to you. Strontium is here, so its atomic number was 38, and you're done. All right? To find neutrons, what do you know you have to do to find neutrons in number 3? Neutrons require you to do what? Subtract. So if you look here, osmium is number 76. So 76, and what number did I give you? 190. So 190 minus 76 gives you what? 114? Okay, so 114. All right, number 4. This time I asked for all the numbers. So how many protons does zinc have? 30. How many electrons does zinc have? 30. So you got 30 and 30 because they got to be the same. And then you take 66 minus 30 and you get what? 36. All right, number 5. Several people called me over and said, I don't remember how to do mass. What do you do to find atomic mass? You add what two things?
14 and 16.
Protons and neutrons. So 14 plus 16, you get 30. All right, number 6. What do you use to find the element? The electrons, the neutrons, you have to add them and get a mass.
Electrons.
The electrons are the same as the what? The atomic number. So the atomic number is 25. So when you look up the atomic number 25, you find manganese, Mn. All right, number 7. What's the number of electrons in an atom with an atomic number of 12 and an atomic mass of 24? Electrons are the same as what? Atomic number. So electrons and atomic number are the same, so it's just 12. All right, number 8. What is the atomic mass of an element with 23 electrons and 27 neutrons? What do we do to find mass? You add. 23 plus 27 is what? 50. Number 9. What's the identity of an element with 13 protons, 13 electrons, and 15 neutrons? What tells the element? The protons. You look up 13 and you find aluminum. All right, what's an isotope? Same atomic number, different atomic mass. So you could have said same protons, different neutrons. All right, so I'll write 11 down because that one's got more numbers in it. All right, so for 11, you had to find protons, neutrons, and electrons for both. So sulfur has an atomic number of 16. So the protons will be 16, the electrons are 16, and the neutrons are 32 minus 16, which is 16. For 34, protons are still going to be 16, the electrons are still going to be 16, but the neutrons are going to be 34 minus 16, which is going to be 18. All right? What has to be the same? The atomic number, or you could have said protons. What has to be different? The mass or the neutrons. Okay? So for same, you could have said protons, or you could have said atomic number. For different, you could have said mass, or you could have said neutrons. Either answer works there. All right. For number 13, are the following different elements or are they isotopes? For A, what could you tell me here? What could you tell me about those protons? Are the protons the same or are they different? Protons are different. That tells us this one is a different element. Okay? If you look on the periodic table, 6 protons is actually carbon, and 7 protons is nitrogen. Okay? One's carbon and one's nitrogen. They're different elements. In B, element T and Z both have an atomic number of 20. If they both have an atomic number of 20, are they a different element or are they the same? They're the same, so that means this one is a what? That one is an isotope. It's actually calcium. Okay? We know it's an isotope because these two are what? They're the same. Okay? They got to have the same atomic number or the same protons to be an isotope. If they don't have that the same, they're not an isotope. Does that make sense? Okay. Now, we have to talk about ions. Everybody with me on doing that? Okay. Because ions won't make sense to us if we can't do this. Okay. All righty. Get rid of that for a minute. Find your notes. Let's talk ions. All right, so what's an ion? An ion is an atom with a charge. Okay? It's an atom with a charge. So up to this point, everything we have done, the atoms have been neutral. Oh, well, why are you doing your time? All right. You actually 20. That'll get you to you don't have to do that. All right. So an atom with a charge is an ion. Now, examples of this for what we're going to do today will be something like Na with a +1 on it, or an Fe with a +3, or an O with a -2. Everything that we did yesterday or that we just practiced, did it have anything that had a plus or a minus sign on it? No. Everything that we practiced had an equal number of protons and an equal number of electrons. Now, we're going to talk about things where the protons and the electrons are not equal. Okay? So, what does a positive oxidation number mean? So I put two examples up there where you have a positive oxidation number. Okay? What it means. All right? A positive oxidation number means that you lost electrons. Now, if you lost electrons, you can say it the way William did, which means you have more protons. Okay? Now, because in chemistry class, we think about this as electrons, and we never talk about losing or gaining protons, I don't ever refer to it that way. But you can think about it having more or less protons. But we don't lose or gain protons, so we don't write it that way. But you can think about it as, oh, I have more protons, that's why I have a plus charge, okay? But you actually lost electrons. So the flip side of that is, what does a negative oxidation number mean? Okay, you didn't lose any protons. That's why I don't like to use that. Talk about protons. You gained what? You gained electrons. So if you gained electrons, you just have less what? That's right. There are less protons. All right, so there are less protons. Because you never, ever lose or gain a proton. The protons are in the nucleus. They're not able to be lost or gained. They're fixed. So if you have 6 protons, you're carbon. You can write with a pencil on a piece of paper today. But if you have 7 protons, you're nitrogen gas. You're the air that's in the room. Okay? They're completely different elements. You can lose an electron and still be the same element. You cannot lose a proton and be the same element. Okay? So when we talk about losing and gaining something, we lose and gain electrons. We can talk about who has more or less protons, but they're not lost or gained. Yes, sir. They would just be a different element. They wouldn't physically change from carbon into nitrogen in front of your eyes. No. Yeah, no, that would be cool, but that doesn't happen. All right. Does everybody have what they need, or do I need to wait? Need to wait, Alexis? All right. You're good? Okay. All right. So this looks just like what we did yesterday, does it not? What's the only difference?
The negative is the positive.
It's got a negative and a positive. So we're going to do what we did yesterday, except we're going to figure out what to do with that negative and that positive. Okay? Jacob's working really hard today. Pay attention so you know how to do it, particularly since you missed yesterday and going to miss tomorrow. All right. We got one written down? Now, what did we say this was yesterday? Okay, so that was the mass. What was this yesterday? This is the atomic number. And I'm going to give you a new vocabulary word that we're going to use. Did any of you learn to write formulas in middle school? Did any of you learn to do something like, maybe one of your teachers taught you something like Mg had a 2, Cl had a 1, and you had to learn how to write formulas like this? Anybody remember doing anything like that in middle school?
Yeah.
You remember doing that? Okay. We're going to have to do it in here. You're going to have to learn where the numbers come from and learn how to do this. We're going to do it right around Christmas time, that week of benchmarks. Okay? Now, this is called an oxidation number. It's called an oxidation number.
They gonna use that.
Huh?
Is that like questions?
Yeah. And you're going to have to learn how to find the oxidation numbers on your own. Like you're going to have to be able to figure out that O is a -2 without me giving it to you. Okay? Now, it just tells how many electrons are lost or gained. And we'll talk about that down the road. But it's called an oxidation number. Now, we want to find the protons. How did we find the protons yesterday? That is correct. All right? We used the atomic number. So what is the atomic number? Is that any different from yesterday?
No.
No. Same thing. Yes, sir.
It's basically like the -2, like taking +2 electrons, so electrons would be.
Yes, that is correct. All right, so for the electrons, because this is an ion, this is the only step that is different. All right? So, how did we find the electrons yesterday? All right, they're the same as the protons, right? Which means we have 8. Now, this is the only new piece. What does this mean? We cruise right here. A negative oxidation number tells us what? We gained electrons. Now, a lot of people go, so it means the opposite. Minus means I gained. If you want to think about it that way, knock yourself out. Okay? I don't care how you remember it, as long as you know -2 means that you gained 2 electrons. So if you gain 2 electrons, we add 2, and we have how many electrons? 10. Now, neutrons still work the same way. What did we do to find neutrons yesterday? Subtract what? Mass minus number. So the mass is what? 16 minus 8, and we get 8. So the red that I wrote on the board is just like yesterday. The only piece that's different, I wrote in the green. So does everybody see what's different? Yes? Yeah. Now, if we look at this one, How many protons would there be, Sierra? How many protons would I have in that one? 13, good. How many electrons would I have initially, Alexis? Okay. Damien, what does this mean? I'm going to subtract it. That means I lost 3. So when I subtract it, I get 10 electrons. All right, and what am I going to do to find my neutrons? Yes, ma'am. Oh, okay. I was going to call somebody different. Jacob, since you wanted to answer, go ahead.
27 minus 10.
All right, 27 minus who?
Oh, 13.
Minus 13. Okay, we don't use the electrons. We use our mass minus our number. And so we get 14. Okay? Questions about how we did that? Everybody with me on it? Okay. Y'all do those two. And I'm going to call on 2 people to come put it on the board. All right, we're ready? So, let me write 6 things up here so I can get 6 different volunteers. All right. How about I get Raul to go put the protons up there for I? Good. All right. And the electrons for I, how about Janiyah? Good. Any questions about how she got 54? She added that 1, 53 plus 1, because they're the same, and then she added that minus 1. It's gained 1, so she added 1. All right, and my neutrons, how about Roy? I assume that's right. 127 minus 53, 74.
Yes.
Okay. I get to that one in my head. All right. Are we all good on the first one?
Yeah.
All right. How about Nathaniel? Protons. Okay. And electrons, Mr. Hernandez. Good. Anybody have a question about that one? Okay, and the last one. About Mr. Riff. You don't want to do it or can't do it? Okay. How about, what was that? Okay. How about Alexis?
I do
It's only one number. Forgot already?
I know. Yeah, I did.
Okay. Questions about any of those?
No.
Caleb? In order to find neutrons, we subtract what two numbers? We always take our mass, which is 40, subtract our atomic number to get neutrons. Okay? Questions? Anybody? Did you just not want to, or did you not remember from when you did this earlier in the year? Okay. Now, suppose we want to go backwards. Okay? This is like yesterday. We want to go backwards. All right? They give us this. And we're not going to write it in hyphen notation, but we are going to write it in nuclear symbol notation. What's different about this one and the ones we did yesterday? Okay, they do all have different numbers. But there's something that should jump out at you. Yes. Okay? You need to notice that your protons and your electrons are not equal. Okay? Your protons and your electrons are not equal. Okay? If they're not equal, that means it is an ion. Okay? That tells us it's an ion. It's going to have a little plus charge or a minus charge on it of some type. Okay? Now, we need to figure out the same kinds of things we did yesterday, though. All right? How many protons do I have? So what's my atomic number? Okay? My atomic number is 15. All right? So, William yelled out phosphorus. Is everybody okay with how he got phosphorus? How would we know it's phosphorus? What? We look where? On the periodic table. Alize's looking down there, does like this, like ain't everything he's saying. All right? We have to look on the periodic table. We have to find number 15. All right? And when we do, that tells us that it's phosphorus. All right? What other two things do we need once we know it's phosphorus? We need mass. Can we just look at the table and go, oh, the mass is, and write it down? Okay, we have to find the mass. Okay? Mass equals what? What two things have we learned we add together to get the mass? All right, Alize is going to be quiet. Because the rest of y'all are going to talk to me. William can't answer anymore either. Okay? Protons and neutrons. All right, so how many protons do I have?
15 protons and 16 neutrons.
So 15 plus 16 is 31. Okay, so now I got a mass, and now I got an atomic number, and I know my symbol, right? So that's all we did yesterday. But what do I do if my protons and my electrons are not equal? I need a charge. All right, so now we're going to subtract these two. So 15 protons subtract 18 electrons All right, equals 3. Now, you put a positive or a negative on it, depending on which number is bigger. Do you have more protons or more electrons? What charge does the electron have? That's how you decide, okay? Since we have more electrons, we're going to put a negative on it because there are more electrons. If there had been more protons, I'd have put a what on it? A positive, okay? Because I could have just as easily have written 18 minus 15 here and gotten a positive number. It doesn't matter which one you subtract first, okay? You decide who's positive and who's negative based on which one you have more of. So now we write the symbol, okay? So what's my symbol? We write a big P for phosphorus. What number goes at the top, the mass or the number? The 31. What's the atomic number? 15. And what is my oxidation number?
-3.
So -3. See how we did it? Yes or no?
Yeah.
All right, let's try another one. All right, so try my one down here at the bottom. All right, down here at the bottom. So we got 14 protons, 10 electrons, 14 neutrons. All right, what do I do first? What do I know? Give me something I know. William's not talking. William cannot talk. Alize cannot talk. Both of them know how to do it, and they know everything I've asked. They cannot speak. Period. Okay?
Period.
They can chew on a piece of straw, paper, or they can just keep their mouth shut. They cannot answer another question today.
Well, so we know it's ion because the proton.
All right, they know it's what?
It's ion.
All right, they know it's an ion. All right, because these two things are not what? They're not the same, so we know it's an ion. Okay, that's good. So it's got to have a plus or a minus. Damien? All right, he knows the atomic number is 14. The atomic number is 14. Jacob, what were you going to say? Okay. What else do we know?
It's going to be a positive because of 14 bigger than 10.
Okay, the protons are bigger, so that means it's going to be a positive number because the protons are bigger. That is true. Do you know what positive number is going to be?
4.
All right, it's going to be a positive 4 because when you subtract 14 minus 10, you get 4, and we do know it's going to be plus 4 because you have more protons this time. Okay, and protons are positive. Okay, so we got a plus 4 and atomic number. What? All right, how'd you get the mass?
No, it's not. No, it's not 24.
How do we get the mass?
28.
It's 28. It's 20.
Bye, Mari.
14 plus 14.
14 plus 14 is 20.
14 plus 14 is who?
28.
28. All right, so now we have a mass, we got an atomic number, and we got a charge. What's the last thing we need? We need one more thing. All right, Bree, Damien, and Jacob are out. They can't say anything else about this question.
You need to, can you repeat the question you just
We need to know what?
said? The number.
We got the number. We need to know what's attached to the number.
Element.
The element. Okay, good, Roy. So what's the element? Silicon. How do you find that?
14.
He looked up 14 on the periodic table, and he found silicon. Okay, so now we need to write it. All right, Roy's out of the running.
Oh.
All right, so what do we do? Same question. We got all of the numbers. He's told us that silicon. We got to assemble it all. We got to make it look like these things. So what do I do with this to make it look like that stuff? All right, put the 28 on top. You cannot answer. You've been stricken.
Plus 4.
And 14 on bottom.
14 on the bottom. The plus 4 is going where?
On the S.
On the S.
The S.
The SI. So the plus 4 goes where? on the top right. Y'all don't know your right from your left. All right? That's all you do. Questions? Can we try another one?
Yes.
Okay, we can answer on the next one, right?
Yeah. So let's say that we have,
Yeah, you can. Bye. Okay, so it'll be
all right, do it yourself and don't yell anything out. See what you can do first. And then I'll ask questions and let you contribute. That way everybody has a chance to see what they can come up with first. All right, we have enough time? Give it a shot?
Yeah.
So, tell me something you know. Somebody.
16 minus 18, and will equal -2.
Okay.
Trying to figure.
So Jacob's answered, he's now stricken from the group. All right, so he said 16 minus 18 gives us -2. All right, Alexis, what were you going to yell out? 16 is what? All right, so the atomic number is 16. All right, Alexis can't answer. Somebody else give me something they knew.
Sulfur.
All right. All right, so I got sulfur, and I got the mass is 32. All right. Do we agree with everything that's up here?
It's 34.
All right, so tell me how you get that. All right, so how'd you get that? How do we get this? Got to add 16 plus 18. All right, neutrons plus protons is 34. So this should be 34. Okay, that's correct. Okay, so do I have everything I need?
Yeah.
Okay, what do I put in the middle?
34.
S. And then what goes at the top? And what goes at the bottom? Okay, what goes up here?
-2.
All right, you got it? Yeah? Okay. All right, we're going to talk a little bit about electrons, and then I'm going to give you a little bit to practice tonight. Not a whole lot, just a little for the quiz tomorrow. All right. Because I really do want to be able to work on building the models tomorrow. Particularly if we're going to wind up missing a school next week.
Okay, this weather needs to stop because I don't know.
It's killing me in chemistry. All right, so there are two kinds of electrons tomorrow that you're going to have to label and make sure that are marked and counted on your Bohr model. Now, they're called inner shell electrons and outer shell electrons. Now, the outer shell electrons also have another name, and I'm going to use both of them like I have in many other topics, because you never know which name you'll see on the exam. So, sometimes we call them outer shell electrons, sometimes we call them valence electrons. So, I will, again, just like when we did waves, and then we call them compressional, and what was the other name? Longitudinal. We will use both names. So if you see one or the other on the exam, you will know both names, and you won't be like, dang, what was that other word Ms. Wall said that one time? And I have no idea, or God bless, you'll see it and be like, I don't know what that is. Okay? You'll know these. Now, let me see if I left space to talk about them. Okay. The outer shell electrons are the electrons on the outer most ring. Okay? Outermost. Now, sometimes we will say, and we haven't really gotten to this yet, we will get to it next week, or we can say, or the highest energy level. Because I'll do more with energy levels next week. Getting ready to label an energy level, that'll help. Now, inner shell electrons are essentially all other electrons. Inner shell electrons can be on one ring, or they might be on 3 rings. But an outer shell electron can only be on how many rings? 1. Okay? There is only 1 ring that makes up those valence electrons, a singular ring. But inner shell electrons can be on 1 ring, 2 rings, or 3 rings. Now, if you spent some time talking about Bohr models, or you had a decent 8th grade experience, you may have looked at Bohr models in 8th grade. Okay? If you're one of the people who had the subs. No, you didn't. Okay? Were you here in 8th grade, Zaya? No. Okay. A lot of them were here, and they keep telling me they had subs in 8th grade, so they said they remember nothing. Did you have a sub in the 8th grade, a real science teacher? Okay. Do you remember doing Bohr models in 8th grade? You've probably done them at Central, so you should remember these. All right. So let's say this is your Bohr model, and I'll give you a minute to draw it. This first ring has 2 dots. This ring has 8 dots, and that has 2 dots. So 2, 8, and 2 is what I've drawn up there. Okay? I have 2, I have 8, and I have 2. Is what I have drawn. And we're going to talk about the inner and the outer shell. There's 3 rings. And on the first ring, I have 2 dots. The middle ring, I have 8 dots. And the outer ring, I have 2 dots. All right, we have time to draw? He's just not right over there. Huh? Are you okay? All right. All right, so if we look at the 3 rings, I'm going to label them 1, 2, and 3. All right? they're referred to, all right, some people call them rings. Rings are energy levels. Okay, rings are the same as energy levels. So those things are your energy levels. Now, only one of those rings or energy levels is an outer shell. Which one is the outer shell? Number 3. Okay, your outer shell is this one. All right, or energy level number 3. Okay? So, if energy level number 3 is the outer shell, how many electrons are in the outer shell? What? 2. Okay? So it has 2 electrons in the outer shell. How do we know there are 2 electrons in the outer shell? There's 2 dots. That's exactly right. So tomorrow when you build yours, if you need 2 electrons on the outer shell, you'll put 2 beads on the outer shell. Now, the inner shell has how many rings? 2. All right. Energy level. 1 and 2 are on the inner shell. So that means that there are how many electrons on the inner shell? There would be 10, because you would say 2 electrons plus 8 electrons equals 10. Does everybody see how we did that? So we took these 2 on the first ring, and then we took these 8 on the second ring and added them together. Okay? Only one ring is the outer shell. Once you say that this third ring is the outer shell, that makes everybody else what? Inner shell. Does that make sense? If you're one of the people tomorrow that gets 4 rings, if the 4th ring is the outer shell, rings 1, 2, and 3 then are what? Inner shell. If you're somebody who gets 2 rings, the second ring is the outer shell, and that means ring 1 is what? The inner shell. Okay? They vary. Everybody with me on that? Now, the last thing we're going to do that's new today, because I'm going to save that for tomorrow, all right, is how many electrons can each ring hold? Okay? Because you need to know the rules for this, because you're going to have to build your own models. Okay? It's what? No. I'm with you on the 2 and the 8. All right, so ring 1 holds 2 electrons. Okay, the most that you can put on ring 1 is 2. All right, ring 2 can only hold 8 electrons. Now, the odds that I will give any of you less than 10 electrons tomorrow is remote. Okay, the vast majority of you, probably everybody, will have more than 10 electrons. So you're all going to go into 3 rings. I might be kind to give 1 or 2 of you less than 10, but again, remote chances of that. So the third ring can have 8 electrons. Now, it can actually hold 18 electrons in sublevels. But that is not something I'm going to teach, okay? If Zai had that at Central, more power to your teacher over there, but I'm skipping that stuff. Did he teach it at Central? Okay, I'm not teaching it either. The 4th energy level can also hold 8, or it can hold 32 in sublevels. Our curriculum actually says that you're supposed to know that 18 and 32 stuff, but I do not for the life of me understand why, because it tells me not to teach anything about the sublevels. So I'm not going to talk about anything with those sublevels. So for y'all, I'm not teaching these 2 pieces. So you're going to use the rules tomorrow, and I'm going to show you how before I actually give you supplies to build. Now, for homework tonight, what we're gonna do. We're gonna do the odds in 1 through 9. What's that keep? 5 questions? We're gonna do the odds in 1 through 9. Where you going? I'm gonna have to hand one to Caleb. Roy, take that. Give one to you and William and Caleb. Since John just bailed on his desk. 1 through 9. There you go. All right, we're doing 1 through 9. Odds only. So 1, 3, 5, 7, and 9. 1, 3, 5, 7, and 9. Put your calculators up.